Okay, thank you, and welcome to everybody for joining us for another in the series of Jain Irrigation's virtual Lunch and Learns. I'm Richard Restucia, Vice President of Water Management Solutions, and I'm really excited about the presentation today on combining Jain Irrigation technologies to amplify individual benefits, right? It's using individual components gets you so far, but when you start to combine the technologies, you really create some synergies, and it's exciting to see that. The other thing I really like about today's presentation is that we talk a lot about theoretical applications of irrigation and what's happening in the perfect world. What Michael Pippen's done today is gone through and kind of shown us a few case studies where there's been challenges or problems, and how did they problem solve these challenges, and how did they create these solutions. And so it's a lot more practical education today, which I really enjoy. And then the other thing I really enjoy about this presentation today is Michael Pippen, the presenter. You know, Michael grew up in agriculture. It's in his blood. Grew up on a family farm, and then used that experience to enhance and amplify his career in irrigation. You know, he's been in irrigation really all his life. And is really passionate about agriculture and helping other growers. And then I also know, you know, he worked as the chair of the Irrigation Association Certification Board. And so not only has he been working for himself and helping the companies he's been paid to help, he has also helped many other people in irrigation as a courtesy. And so I really appreciate that when people are just helping other people. So with that, I'm gonna welcome Michael. And Michael, gee, you've got the best Zoom wallpaper I've ever seen, right? So where are you today? Where are you broadcasting from there?
Well, Richard, I appreciate the kind introduction there, and I appreciate the opportunity to share a little bit of what I've learned in the last couple of years with some growers combining these technologies. And right now I'm at our family farm, which is in the northeast corner of Louisiana, right off the Mississippi River. And so that's where we're social distancing from today still, and that's where I'm broadcasting from. So I appreciate the opportunity to share a little bit. And I have been really fortunate to work with and for a lot of really talented people in the agriculture and specifically the irrigation space here, and that's, you know, we're gonna show off a little bit of that today in the next 20 or 30 minutes. But I really like the term you used there earlier, Richard, in synergies. I was kind of struggling for the terminology I wanted to use to focus on, you know, really the idea of using different components, improvements in your system, and how well that is, but really how putting them together you get more value than any one of them individually. So I appreciate the word synergy there. I was looking for that all week, so I like that idea. What we are going to do today, I'm also going to plug some of the other webinars that we've done over the last couple of months. A lot of these are really well done, and I learned a lot from them. We have some talented people that we've worked with and that I work, you know, coworkers that have put some of these on, and I encourage you to go back and look at some of these. If you haven't seen them, we post them on our on YouTube, or you can just Google search webinar Jain, or you can go to our website, Jains with a S, JAINSUSA.com/trainings. And you can get into the weeds a little bit more with some of these topics I'm going to cover, but I'm going to try to hit the high points. And if you have any questions, we'll have some opportunity for that as well. But a few weeks ago, or really almost a month ago, Michael Darwinko, which is one of our landscape sales managers, and he spent a tremendous amount of time out in the field as a landscape contractor, looked at the components of a drip irrigation system. And while his applications were kind of, you know, landscape focused more than mine today being ag focused, the components really do the same thing. They serve the same purpose. In a lot of ways, they look a lot alike, right? They're similar, and they're definitely similar in their necessity. And so he talked a lot about the importance of filtration and why we do that, and how to protect our investment with the filtration and some other components. And so that's going to be one of the technologies that we look at today, how we improve filtration on these farms that I'm going to discuss in a moment. Really the second technology that I'm going to showcase today is something that Kevin Stewart, our ag sales manager, talked about 2 weeks ago. And why does Jain produce 4 different drip tapes, right? We produce 3 different styles of drip tape, and within one style, we produce 2 different product lines. So, really 4 different drip tapes that we produce. And Kevin went into the details of why, right? There's particular attributes that each one of them offer. There are, particular applications that they fit better or worse in. And we're going to talk about one of those today, Chapin Deluxe, in a little bit more detail. But again, go back and we can, you really should look at those and kind of get a little bit broader application of drip tapes when you get a chance. And then finally, the third piece that we're going to talk about today is our technology piece. And we've had several presentations around our Jain Logic product line, which is our monitoring and control product line, remote monitoring and remote field control. And we've talked about the software, how it works and what its purpose for, what its applications are. We've also talked a little bit about our NDVI satellite ET calculator and some of the satellite imaging and how you can use that in conjunction with ground truth field monitoring and control, and how that all goes together to help us really understand the when do we need to irrigate and how much. So those are going to be kind of the 3 technologies that we put together and really discuss around a group of growers that I've gotten to know over, really probably close to a 10-year period when I was with distribution, and then now in manufacturing. These guys are located in what we call the Boot Heel of Missouri. And Richard's first question to me is, where in the world is the Boot Heel of Missouri? And so this is the Mississippi River right in the central U.S. Missouri, kind of this southeast corner of Missouri. And then here, Arkansas, Tennessee, Mississippi, and Louisiana. If you look at where I'm at, I'm kind of in this crook right here where you see the river jogs to the east, the Mississippi side, and back down. That's kind of where I'm at right today, right in this northeast corner here. If you see, to kind of explain to what these farms look like, you can see the light shaded area of this Mississippi River Delta, right? When it turns green, obviously those are trees. This light shaded area is the Mississippi River Delta. Not all of it, obviously, but a majority of this is really profitable, good soil. It's sandy loam. It gets pretty sandy in some places, really sandy, almost as sandy as some of the stuff we see in Florida. And then obviously it gets heavier towards the woods or maybe a bayou or a slough, but in general it's kind of sandy loam soil, very flat, almost no elevation change. And you can see it here, it stays kind of in this Arkansas area, and then it scoops away in here into Mississippi, and then here in Louisiana as it goes down into the Chaffalaya Basin. So big area here. A lot of commodity crops are primarily produced here. This area here in Arkansas is kind of this rice area that you see, but right around this river is where we primarily grown cotton. And even though the market, like Richard and I was talking about previously, is not really great, and here behind me you see a lot of soybeans that once was cotton ground. Here in this Boot Heel of Missouri, they still grow a lot of cotton. That's what these producers primarily do. I'd say our average producer that we're working up there grows several thousand acres, 2,000, 3,000, 4,000 acres, and most of them are 2 generations farming, dad and son, and they primarily grow commodity crops, cotton, corn, soybeans, a little bit of rice. But what they do that's interesting is say, well, how did Jain get involved? These guys have produced watermelons for quite a long time. They've used it as a rotational crop. I don't know how they got started growing watermelons in this Boot Heel of Missouri area or this northern Arkansas area right here. But one of the main reasons for it is they're kind of an in-between market. They are a late summer watermelon market. So right now, or the last couple of weeks, we're picking really heavy watermelons in Florida and South Georgia to try to beat Memorial Day, right? Everybody wants a big Memorial Day watermelon. And so that's the Georgia and Florida market is really planted to try to supply that. And as you move up the East Coast, there's really a gap between some of this Georgia watermelons and before you get up into the bigger watermelon producing states like Indiana or the Del Mar Peninsula over on the East Coast. Missouri kind of sits right there in that middle point, and to where they can produce melons and they can get in before Labor Day, which is also kind of 4th of July, Labor Day is kind of their typical market. So it's a great crop in terms of market, kind of an in-between market, but it also is a great rotational crop for what they're doing. So instead of pulling out, hundreds of thousands of, well, not hundreds, but individually, they probably could rotate or need to rotate thousands of acres into a different commodity crop. They can take several hundred acres of watermelons and move them through their fields as the seasons go. And so that's kind of how these growers look. That's where they're located. This is really kind of a typical field that we're working with, which is you can see the center pivot line here. These are big fields. This one's kind of irregular shaped, and I think it shows a good example of what we're trying to do, where this is the commodity crop planted. Let's call it cotton. He's got a 1/4 mile pivot. This is a 1/2 mile by a 1/2 mile. It doesn't have all this field, but a 1/2 mile by a 1/2 mile. So it's a 160-acre field, and he's got a 1/4 mile pivot that covers this whole section. So if you want to think of this as kind of 4 quadrants, those are basically 40-acre quadrants. So he would grow cotton on this 1 or 2 years, maybe 3, and then he'd say, well, I'll maybe put this 60 acres right here into watermelons, and he may grow that for a couple of years, and then he may move over here and plant this 40 or 60 acres, or here, or go to a different field, not ever really producing thousands of acres of watermelons, but rotating through several hundred. And if the market conditions are right, he may move from 160 to 260, or from 250 down to 150 based on the markets that were following him or preceding him. That's kind of their growing practices. They used a 5/8 high flow drip tape on these systems, and they kind of had these movable trash pumps that they moved around. And very briefly, to talk about our water source, we use a lot of well water, a lot of groundwater, but it's not coming out of an aquifer. We, being so close to the river and other tributaries, not just the Mississippi River, we've got good water at about 40 feet. We have some wells we'll look at here in some pictures, and they may be thousands of gallons a minute in less than a couple hundred feet. So we've got plenty of water. What they would do is they'd make these small casings, 2, 3, maybe 4 inch, but a lot of 2-inch casings, kind of put a little trash pump on it and a small screen filter, and they would tie onto these sections, these 40, 60 acre sections, and they would irrigate them. And you say, well, that doesn't sound very sophisticated, and maybe it wasn't, but it was very portable. It allowed them to react very quickly to the market conditions. If they needed to plant an extra 40 acres, they could go drop one of these wells in very inexpensively, grab their components, and go, right? So while it might have been the most sophisticated system, it worked and saved their needs very well, and they were very profitable doing this. But what was causing the problem? So why are we here if they were doing things that were working for them? And the biggest thing that I think kind of got us engaged here with the dealer, and then kind of bringing me in later on, was their water quality was poor. We have a lot of water in this Mississippi River Delta, thousands and thousands of gallons a minute, very shallowly, but the water quality is pretty bad. A lot of iron in the water that is suspended and can precipitate into our emitters, clogging things up. And if you had an established well with a metal casing, we have a lot of iron bacteria that grows in the off season that can really gum things up, right? It's not great water, right? Let's just put it that way. So that was causing a lot of problems. And also the, the long row lengths were causing a lot of problems. If you look at that previous slide where they had those 1/4 mile runs, that's not necessarily too long for a watermelon production field. But with a 5/8 tape product, they were having a lot of problems running these lengths, right? And the 5/8 high flow is just kind of something they fell into, nothing necessarily specific about the selection, just kind of a common product there. So they're having problems really with a lot of lay flat and a lot of expense that way. And the crop rotation was also giving them a little problem. You go, well, what a crop rotation is good, right? And it is. And from a growing perspective, it was very good for them. But what it really challenged them with is they may have a field that they've never put watermelons in, and next year it might move. And so they were always trying to learn how this drip system worked with their watermelon fields, because they were always moving. They had some that they stayed in, that were really good, and for whatever reason, they like to keep those in there for multiple years. But a lot of times they're 1 or 2 years and then moving. So they're always trying to figure out how in the world to water this stuff, because it was new fields, new cultivation practices. And then obviously the labor of setting up all these pumps. And, they've got a lot of pumps, a lot of zones, a lot of things, and that's just a lot of pain.
So, Michael, we've got a whole host of questions right now. So if it's okay. That was a great introduction, sure. And it created a few questions. First question we have is, so they're irrigating with center pivots and drip is at the same time. Is that correct? Can you kind of expand on that a little bit, please?
Not always. Yes, in some cases, you would see some watermelon production that had no drip on it, and they just ran a plastic mulch and a center pivot over it. There would also be some furrow irrigated fields here where there was no pivot. I would say by and large, they drip irrigate their melons. when they typically didn't drip irrigate their melons was when they got a late contract, market conditions, and say, hey, can you plant another 40 acres? And they didn't have time to get plastic or drip tape or anything set up, and they go find a pivot corner and drop it in. So in general, no, they're doing almost all irrigation with their drip system, although there are a few outliers.
Yeah. Okay. And then typically, I mean, this example is 160 acres. What's the average size farm there? What are people working with?
I would say most of these commodity crops are in excess of 2,000 acres. They're probably, a lot of these guys are in the 5 to 10,000 acre range. So they're growing major acreage as commodities. I would say from a watermelon production, most of them are under, they definitely all would be under 500 acres of watermelon production. Most of them would be around 100 to 200 acre. And there's still a lot of small growers, kind of a co-op there. There's a lot of 50 acre growers here. So it's not a huge market. And most of the individual growers are probably growing, less than 10% of their crop is watermelon.
Yeah. Okay. And then for the irrigation systems, everything is filtered. Is that correct? Or?
That's correct. Now, their center pivot stuff, they probably would not. We'll go into a little bit about some of the chemical treatment there and the iron bacteria, but their overhead systems probably do not have any filtration on it. All their drip systems should. They've been told they need them. But yeah, especially what we're working on now is all filtered. Yeah,
so I raised my eyebrows a little bit there when you say should, right? We always say that. Lots of times the percentage is much lower. Are half using filters? Is it more than half, less than half?
I would say more than half. Most of these guys have been around the drip system enough, and with the water quality problems they have, all of them, including myself, have learned my lesson without adequate filtration. And so I would say by and large, these guys are filtering of some sort.
Yeah. Okay, great. Thank you, Michael. That catches us up. Thanks.
Good, no problem. So we talked about what was causing the problem with the systems that were actually relatively effective and some of the issues they were having. So what was our solution here, right? And the first thing I think that mostly we wanted to address, and really the growers wanted to address, they knew it was a problem with this clogging, right? They're having a lot of water clogging problem here. And we can spend all day talking about filtration, but there's a couple of options here. And we're kind of growing these systems together. So I'll definitely pause for a few questions at the end here. But we're moving them off of these trash pumps and trying to get into larger systems that we can get just better filtration, right? A better filtration option. And also, get away from some of these small trash pumps and add in some of these labor savings. So what we proposed here, and I'm using the collective we have a dealer that's involved in this and doing all this design work, but we added on to this center pivot well here. And we made a manifold and used our Jain Spin Clean screen filter. Another good option for this would have been media filter. We did not use the media filter for a couple of reasons. Primarily, well, it's pretty high input cost, right? Media filters are expensive. From a filtration standpoint, you could definitely make the argument from just filtering that they're the best option for this application and almost any application. But with these guys moving them around a lot, or maybe having to add acreage pretty quickly, having a media filter would almost have to be on a trailer, not on a slab. So that presents its own problems. And also, we're talking about watermelons here. We're talking about 90 days worth of irrigation. So the other 250 days a year, it's sitting under the barn. So to have a trailer in the way, sitting up, maintenance, these are not things that are used very long, very short growing season. What we decided to go with was a screen filter. And we used this screen filter and sized it so that we could basically have the largest screen element that the system would allow. Screen filters kind of have a high flow and a low flow range. They have a range that they operate most optimally at. The high flow range is really, for our screen filter, really kind of built around friction loss, how much pressure loss or pressure differential you have across that screen. If you get too much, it could blow it out the screen, right? Just pushing too hard against that screen. The low range of that filter is really not so much based on the screen itself, but it's about how to keep the water moving through this screen element at a high enough velocity. We put what we call a spin plate in the top of this element. It forces the water to cyclone inside this element, creating a lot of turbulence, disrupting and breaking the debris off of the screen when we open this valve and dump it off the ground. If the water is going too slow in here, like if your filter was too big, we wouldn't have enough velocity, wouldn't stir things up good enough, and we wouldn't get the debris out. So we wanted something that was economical. We wanted the most surface area for our screen, the most capacity that we could for the dollar. But we also wanted something very portable and would flush itself better than pulling that big old element out and trying to scrub it by hand. So in a scenario here, we didn't always get to this, but if I make an example of where you had like a 300 gallon a minute system, the old setup with a trash pump was probably less than 100. These are like 300 gallons a minute. Instead of taking a 4-inch filter, you can see that 284 to 365 and putting no spin plate in it, or putting the spin plate and leaving all the holes wide open, we would go up to a 6-inch filter and plug some of these holes. Plugging the holes creates the velocity, keeps everything working right on the inside, but now we're using a bigger 6-inch element versus a smaller 4-inch element. And I picked that out and kind of made that example up. But as far as, the exact, that's kind of the goal. Not every one of them get to that. They might be a little outside of it, but you get the idea. You can do the same thing jumping from a 6 to 8 or a 3 to a 4. We're trying to get the most screen element that we can, the most capacity, but also not lose that cyclonic action. So we went with a screen filter, very, economical for the acres. Better flushing to get those things cleaned out quicker. And we also, I would be remiss if we didn't talk about chemical injection here. You can see their chemigation check valve. We put additives in the well to try to kill some of that iron bacteria and flush that out prior to the season. But that was kind of the solution for the filtration side of it. Really going in conjunction with that was a drip tape that was clog resistant. Now these guys knew, and I knew as well, that the filtration was probably their biggest hindrance on the clogging, right? But we can also add some drip tape technology to try to amplify that or to reduce the clogging risk even further. And so what they were using was a 5/8 diameter, 12-inch high flow tape, somewhere around this 0.4 or 0.5. And 12 inches is a great, it's kind of the multi-tool of drip irrigation on vegetables, right? It pretty much works on everything. There may be places that it's better or worse, it could be wider or narrow, but you can take a 12-inch drip tape and put it on just about anything and do well. So we weren't so worried about the 12-inch, but we wanted to get off that flow rate, that high flow rate, and run these longer rows. If you look at a 5.5 or 0.4 gallon a minute per 100 foot, which would be a high flow, and a 5/8 Chapin model, your run length that we recommend is somewhere between 500 and 600 feet, right? So if you go back and think to our model, we would have to feed 2 directions, lots of laterals, lots of stuff going on. By going to a 7/8 product and still a 12-inch and a 0.25 gallon a minute, we can run all the way out past a 1/4 mile length and still keep our uniformities where we want them. Now, our designers have to do a good job of keeping the friction loss balanced in the main line, but as soon as we do that, then we can achieve some really high uniformities all the way past from one of these fields to the other. So that was super important. We improved the uniformity. With the improved filtration, we were able to lower this flow rate. The lower the flow rates have smaller holes, right? We stayed with the high flow because we wanted big holes because we're having trouble clogging. Filtration is solved. We can go to a lower flow rate. Now we can do the larger diameter and run the longer runs. And I'd say kind of the last little piece of technology we stepped in here was going from our Chapin BTF, our standard Chapin, to our Chapin Deluxe. Chapin Deluxe has this continuous filtration inlet. I call it kind of a primary filter inside of the drip tape. So once we go through our spin clean filter that's sized correctly, then there's still kind of this secondary line of defense where this whole continuing filter inlet can catch material and before it can make it through here and get to the primary filtration path into the emitter flow rate. So you've got yet another filtration, again, trying to mitigate that clogging risk. So we've added in this secondary filtration feature. And there's really, in this style of tape, there's really nothing like that in the industry that has this primary filtration track to reduce that.
So, wow. So you get a lot of peace of mind from having all that filtration right in your tape.
Right. I mean, a lot of it is risk mitigation on filtration, right? You could spend, hundreds of thousands of dollars and maybe that's the quote unquote best filtration. But if you don't have the economic piece in place, right, then it just doesn't work in the field, right? You always have to keep your eye on the economic piece. And the Deluxe is a premium product and it does have a premium price. But for these growers, paying that extra few dollars was worth it, right, than trying to manage their clogging drip tape, right? It was really a no-brain decision for them.
Right. And then Michael, your photo of the filter connected to the center pivot connector, was that is that a customized connection? Does somebody sell a kit for that? You know what?
Somewhat customized, right? This the connection coming off the wellhead right here is pretty standard, right? So I wouldn't be even surprised if the grower built this up. Steel pipe, couple of bends in it, weld in a flange. All of this would be built in the manufacturing facility per spec. So I would call it semi-custom. You turn in a drawing and it shows up this way. This is not something that you'd necessarily build out in the field, although you could. These are probably galvanized fittings. And a lot of these you can get epoxy coated steel, like you showed we show our chemigation valve here and our spin clean filters, epoxy coated steel, pros and cons of those coatings. But in general, this would be prefabbed at a manufacturing facility, us or somebody else. And that way the grower's not trying to do this out in the field where it'd rust and break down. So that's why I said this is probably the adapter fitting here. That's probably field made because the distributor just may not have known, right, what we need to do here, right, to kind of make this Z-pipe connection. But you could, in theory, build this as well if you had the right dimensions.
Yeah. Okay. And then, I see the value of sizing up from 5/8 tape to 7/8. Is there a big price difference when I make that change?
It is in the linear feet per drip tape. A drip tape roll basically costs the same, but you get more or less feet on the roll, right? So if it's a bigger diameter, you get less footage on the roll. So it's but the offset of that. So if you look at it foot per foot, the 7/8 is more. There's more material, right? So it's more cost. But for these guys in this application, let's just say you did a 5/8 tape and your wellhead was right here. Like it's you could not have made this run from one end to the other. So you're going to take a large diameter pipe, a lay flat, run it up here and have to run a lay flat across here and make the extra fitting connections and another one here. So it's not that simple, right? And I think that was really a big learning lesson that all of us, work through is, where's that break point at? Besides just the ease of having one header line and one connect, kind of making all that streamlined, but really kind of bringing in the design all together to see where those economics fit.
Yeah, so it's going to more than pay for itself when you make that change.
In this application, it was a push on price or maybe even a savings to go the larger diameter.
Yeah. Okay. Great. Thank you.
So kind of the last solution here that we've implemented really just last year and the year before. Some of these other filtration systems, our dealers have been building these for several years up there and kind of slowly rotating through fields, right? Like I said, all of them are a little bit different, and they're all kind of doing these as needed as the fields rotate through. But the monitoring and control we've been doing with one grower, this will be his second year, and then another grower, this will be his first year. And we could spend hours looking at how to read charts and graphs, and I would love to do that with anybody that wanted to spend that kind of time with me. This is probably the most fun that we do, is get to show off some of our technology space. But let's just say for this example, blue is wet and this red line down here is dry. All right, let's talk about those parameters. And we want to stay between 2 wet and 2 dry. This is live data that I pulled like Wednesday, so a couple of days ago, of this growers. And this is a real picture that was put in by the dealer this week. Really small transplants here. I mean, this is the live data off this site. And you can see here where he has irrigated 1, 2, 3, 4, 5, 6 times. This is a pressure sensor, so we can see how many hours and kind of figure out that application and what he needs to do. And you can also see the moisture level reacting quickly. This is the guy that we've worked with 2 years. This is, I believe, I remember that's like a Friday. He irrigated, and over the weekend, it dried down really quickly. What we're looking for is these stair steps in this data right here. The flat part is at night when the plants go to sleep, and they wake up during the day, the transpiration increases, they take a big gulp of water. You can really start seeing it stair step here over the weekend, where we didn't see so much over here the week prior. These plants are starting to mature. So really good data. Because it was our second year with us, he kind of already trusted our wet and dry lines, even though we probably will refine them a little bit. We were pretty confident in where we're going to be. And he irrigated, right? This is great, right? He got down the red side. He looked at it on Sunday night or Monday morning and said, man, I need to irrigate. And he turned it on, and he did that, and he brought it above that red line and back in here into the good space. So this is a great thing here to try to answer that last thing and try to bring in that last piece where they had this new crop rotation and they really just didn't have a great understanding of exactly what they needed to be doing in terms of when do they need to run it and how much.
So, and Michael, here, as we read this chart going down, it's just showing us the soil moisture at different levels in the soil. Is that correct?
That's correct. In this application, we'll look at it a little bit in a second here, but you've got a watermelon. So we've got a probe, in this case, it's 24 inches in depth, right? So 24 inches, and we've got a probe, a sensor at 4, 8, 12, 16, 20, and 24. And what we've done here is we've said, okay, what is our root zone? What is a root zone? And we talk with the growers. I mean, these growers know a lot about plant physiology in their area, right? I mean, they really understand these crops and what they do. So, you know, we say, what kind of root zone should we manage to? And in this case, they say, well, I want to manage the 4, 8, 12, and 16. So instead of just looking at one, you know, targeted area, we add, there's a couple of ways to do this, but the way that we do it here at Jain, and the way I kind of like to do it, is to add those together. So you kind of have this sum, excuse me, this sum number here of all these root zones put together. Obviously, depending on the growing stage, this could lean you a little bit too wet or a little bit too dry, but it gives us a target root area for us to try to manage to, rather than a specific, you know, kind of single line in the soil. So what this top line is showing here is the addition of the 4, 8, 12, and 16-inch levels, our root zone, if you will. If you kind of make the next jump of what next with these growers, right? We feel like we've done a lot of good in the last couple of years, and these are great guys to work with. We really enjoyed it. They're really open. They listen, they give feedback, they question what we say, which is great, you know, to say, hey, that doesn't sound right, or explain that further. But what's next for them? And I don't know if this is going to happen anytime soon, but there's always a difference in knowing what to do and being able to execute the plan. And I think we see that a lot in our Jain monitoring and control. We have all this data, but how do we get the knowledge out to the field and actually execute it here? And I think their next step is to automate these things. This is again real fields, 1, 2, 3 watermelon fields. These are not that close together, right? I mean, they're down the road. They're actually kind of close this year. This particular producer, they're not too far, right? These are, you know, a couple of miles apart, but they could be, you know, 10 or 15 miles apart, right? And so in these cases, even though we've redone the filtration station, even though we've got the good drip tape, and even though we got the monitoring that says this field up here in the northeast is good, this one's a little wet, this one's dry, we still have to move around to these places. We actually still have to physically go there and turn these pumps off and on. And if you look at this exact same example that I showed you here, 1, 2, 3, 4, 5, 6 irrigation schedules, 1, 2, 3, 4, 5, 6, maybe 7. So maybe I've got this extra one here. But regardless, you kind of see you got these same irrigation patterns here. This is our root depth, 0 to 24. This is a tool that we offer in Jain Logic. It is a relative measurement tool, so it's showing the change in soil moisture. So what it saw after that irrigation cycle was a change in soil moisture at 24 inches. We did that every single time that we irrigated this week, or the last 2 weeks. And we distinctly said in the previous slide that we don't want to water at 24 inches. We want water to stay between 4 and 16 inches. That's what we want to do. And every time we irrigated, we went past that root zone. So why did we do that? We knew better, and it's not an issue with these growers not understanding what to do or not caring or not being a good producer. It's just physically all the other things they have to do. I have the luxury of working in the irrigation industry and selling these products, so it's my job to get up in the morning and look at this and figure out the actual time we need to do this. He has other things to do, right? He's got crops that he needs spraying. He's got, you know, payroll he has to do, all these different things. And so in this case, you know, when we talked to the grower, he basically he might have called the dealer and was like, yeah, I know I'm running it too long, right? I already know I'm running it too long. And that's where the automation could come into effect here. And I don't know that it's the right thing for them specifically. I think there probably are some solutions they should consider. But here, he knew he had run it too long, but just the ability to actually execute the perfect program. This is a really sandy soil, a new crop. And it acts a lot like some of the strawberry crops that I've tried to manage in Florida the last couple of years, where this every other day or three, 4 times a week irrigation schedule for 2 or 3 hours. It doesn't seem like a whole lot, but these sandy soils just can't hold it right. And we're just right past that root profile every time. and we're basically just spending extra money, right? Where ideally, maybe 3 hours. You can see this case, he only ran a 3-hour run time. That's not a long time. But maybe the answer is 3 hours. He might have been dead on with 3 hours, but it might have been 1 hour 3 times a day, or an hour and a half in the morning and an hour and a half in the afternoon, or maybe it's 2 hours every day instead of 3 hours every other day. And this physically, from what they have to do, is really hard for them to execute that program. They come by in the morning when they have time, and on the way, you can see here, he probably came on his way to lunch, right? 10:55, heading to lunch. He turns it on, gets lunch, goes and checks on the guys out in the field, sets up the sprayer. You get the idea. And on his way back to the shop at 2 o'clock in the afternoon, he turns it off, right? So I think that's really where we, you talk about the next piece of technology that they really are already pretty tooled and set up for with their filtration and their Jain Logic boxes. There's really not a big step in terms of hardware cost into trying to automate this thing and put some sort of level of automation that could really help them execute the program we've been working on. That's kind of what I have. I think before we ask for some more questions, Richard, there's a couple of people I really like to thank. Moore Farms, Marty and Ryan Moore, they've been working with us for a long time. They're up here and allow us to take pictures and try stuff and stomp on things and really spend a lot of time on their farm. Steve Droke is another grower up there that's really worked with us a lot. He's got some Jain Logic stuff up there. And Alex Osborne and Chris Friedman. Alex has done the lion's share of this design work on all these pump stations and everything, done a really nice job and worked with us with specifications and kind of moving around. And Chris Friedman is a salesperson up in that area that, really got us on these farms. And he spends a lot of time working with them with the Jain Logic. So those guys, I really want to appreciate this presentation would definitely not be possible without them and them being willing to share. So I appreciate them. My contact information is there if anybody has any specific questions. I know these guys wouldn't mind us sharing more about it. And then, we'll open this up to questions if anybody has any.
Yeah, so thank you, Michael. That was fantastic. That I'll tell you what, you really brought in a few different factors I hadn't thought about. One of the things that I was thinking about too is, that's a sizable investment in that filtration in your field and your center pivot. I've got a lot of money in that field, right? A big investment. So relatively speaking, soil moisture monitor and Jain Logic is a very small percentage of that total amount. But I don't have a sense yet that 100% of the growers are using Jain Logic or any soil moisture monitoring. Just wondering what your thoughts are on that, and if we're starting to gain some momentum in this area.
All of those things, right? There are a small portion of our producers in general, we go across the U.S. that use any type of monitoring or any type of monitoring or control system. And there's a lot of reasons for that, right? There's a lot of levels to that. But I do think part of it that's allowed us to be successful here. It is a big expense for the filtrate. Really, let's just talk about the filtrate. That's a big expense. Even the way that we did it, you definitely could have spent a lot more money. We really felt like we got them a lot of bang for their buck here, right? And really hit exactly what they were asking for. But it is a big expense, even compared to some of the technology. But it probably is a little bit easier, to physically kind of wrap your hands around these filtration and some of these drip tape selections. And I firmly believe that the dealer working through these other problems allowed them to be able to speak about the technology, which is a lot more abstract, right? As far as I'm going to do this and it's going to make this, or it's going to solve this exact problem, right? And it's a very new type of, how I want to say, a tool for them to use in a lot of ways, right? It's there's a lot of products out there that are always going to make them more money. I know there's people have said, if I spend everything that was going to improve my yield 20%, I'd be growing 1,000 bushel an acre corn, right? And not that that's what we say with Jain Logic, but there's a lot of those things out there that add these costs per acre. So I think with these growers, I will say that none of these growers started with 3 sites, right? They all started with like a one site. Well, one of them had 2, right? They kind of slowly moved in, and we work with them very closely where we invested some time and money. They invested time and money. And that's really how we got this thing off the ground, where we said, we'll help you learn this. but we had a dealer in place that helped to support us locally. You had me at the manufacturer level that was, dedicated to, say, hey, we're going to spend this time on Friday. I'm going to call you. You better answer. And a grower that answered the phone, right? So it has to be all those three pieces together. Once we got that first year over with to where we could really see and grab some of those benefits and we could share it, that's really where we went from, 1 or 2 sites to now 6 sites up there in 2 years. But it really, there's a lot of effort that goes in place, and the growers are a little skeptical, and I think rightly so. Let us prove our value.
Yeah, well, that's what's so exciting about it to me, right, is there's really a lot of partnership here, and everybody's pulling together for the same thing. And I don't think you're going to get, success in this unless you do have the good partnerships. So it's really good that you were able to develop those partnerships. What are some of your secrets to developing those partnerships?
Time, right? Time. It is really, why I spend a lot of time on our primary irrigation business, the drip tapes, the parts and pieces, and those type of things. And I really, enjoy doing that and spending time with our dealers. But the technology is really the most exciting because those are your most loyal customers, right? You really kind of go through the trenches. One example that I always say is that, the growers, a lot of times we tell them this technology and they call and say, what should I do? And sometimes I say, here's what you do. And then oftentimes I say, I don't know, let's talk about it. Let's figure it out. Let's call some of our, we have here at Jain, we have, people that have seen way more charts and graphs than I have, spent a lot more time. We have a big resource of knowledge, right? And so you really get to, leverage our company and our expertise, the dealer network that we spend a lot of times developing. But really the key to building those relationships is just spending the time, which is challenging, right? We're all working hard. We're all, moving fast. But, when we do that, when we ask for that time, I would say have something important to say, right? And the growers are going to listen to you, spend some time. I think that's the biggest thing. And I'm just as guilty as anybody. You get rushed and maybe you don't quite think through everything you're trying to do. But, if you go to those growers and you have something valuable to show them, you may have to ask a couple of times because they're busy, right? These guys are really busy. They're working really hard. It's really hot where they're at, right? And so, to earn that time, make sure you have something really valuable to share with them at that time.
Yeah, I think that's such good advice, right? So often I would work with a sales rep, in past career, and they would say, "Oh, I feel like I'm bugging the customer." And I would say, "If you feel like you're bugging the customer, you are. But if you're bringing something of value, the customer can't see you enough." So that's great advice. I really appreciate that. So, do you have any final thoughts here for growers that are thinking about starting to use technology? Any final thoughts for them, Michael?
I think, yeah. I mean, if I had to say anything, I would just say be open to anything, right? We started pretty simple with the first ask, trying to solve a pretty typical problem in a drip irrigation system. My tape is clogging up all the time. What's going on? Is it a tape problem? Is it what is it, right? And so that's a very, very common question. If I'm a producer, I'd say don't be afraid to ask, right? We may not know the solution, but it may often be not what you're doing, right? It might just be a simple selection guide. In this case, it was a little bit more, right? But it really moved into a more of a system-wide, producing change. And that's not always the case. It may just be a shift in the product line. Maybe moving a valve to a different place. So, I'm a producer, so reach out to your local distribution. If you don't know who that is, reach out to us. We'll put you in contact. We have dealers across all the U.S. and can put you in touch with multiple people that are really, really experienced and have a lot of design and field expertise. So I just say don't be afraid to ask. If there's something giving you a problem, pick up the phone and let's talk about it and see if we can't get it solved for you.
Yeah. So no surprise today, Michael. You were fantastic. Really great information. Motivated me. I think I'm going to use my Saturday tomorrow to put some melons in my garden. Thanks so much for that. I want to thank everybody for joining us today, and hope you all have a great weekend. And like Michael said, don't be afraid to check out our other webinar series. We've got a little over 20 of them loaded now over the last few months, from everything from melons to drip irrigation for your garden. So take advantage of those. There's no charge to watch them. And we certainly appreciate your time. And Michael, thanks again for coming on today and doing this today.
Appreciate the opportunity, Richard.
Okay. Thanks, everybody.